Okay, so I was kind of given the brief to look at what do we think is coming in emergency medicine, what's the exciting things. And hopefully by the end of this talk I'm going to convince you more about reptiles than toys. So voting time, I want to see if you agree with a couple of concepts. And we'll go with green is yes and red is no, okay? And that is, do you believe that ultrasound is the future of emergency medicine? You make my heart very happy. I love ultrasound. It's the world's, my absolute favorite thing. So I would tend to agree with you, ultrasound's amazing. Do you believe that video laryngoscopy is the future of emergency medicine? I'm enjoying that there's a mixture. I quite like that. You can have this argument during tea as to what your opinion means. Just for Craig Wiley and for Neville, do you believe that helicopters are the future of emergency medicine? Can I just tell you that Craig Wiley phoned me last week for a helicopter? I'm just saying. Do you think that a 12-lead ECG able to transmit to a receiving cardiologist is the future of emergency medicine? Now, by way of green and red, how many of you work in a setting where you're able to transmit a 12-lead ECG to a receiving cardiologist? Hey, there's a little bit of green around. There's quite a bit of red, which is a bit sad. I want to convince you, by the end of my couple of minutes, that the future of emergency medicine lies in data and how we use data and what data means to us. There's two numbers up there. For those of you that didn't know, prior to 2017, there were only 4.3 billion available IP addresses. Prior to 2017, 4.3 billion was the total number of IP addresses available. 2017, we came to this realization, and it's linked to something called Fuller's Law, which is that the amount of knowledge we had doubles in a certain period of time. In 1900, it doubled every 100 years. In 1950, it doubled every 50 years. And we're going to this exponential thing where the amount of information we have is doubling more and more rapidly. 2017, they came to this realization that we need more IP addresses. They came out with something called Internet Protocol 6, and they upped the number of IP addresses significantly to prepare the system to hold more information. Because information is really what it's all about. How many of you have published something? Anybody published something?
Green yes, red no.
Published, you're going to be ready for my questions. The publication process is interesting because you take some data, you look at something in the data, you come up with an answer and you publish it. The trouble is, almost never do we look at all the data. You'll have this massive data set and you'll look at 2 or 3 things inside of it. I happen to be responsible for some data sets on patients, and I can tell you I've got about 1,200 data points per patient that are available. And when I get a data request, at most, they ask for about 5 or 6 useful data points. Nobody ever asks for all 1,500 data points. Why is that? Because nobody can analyze 1,500 data points for, at the moment, I think we're sitting on about 1.6 million patients. Nobody can do that. Can you imagine the statistician that has to be involved to be able to analyze that amount of data? So what we end up with is this sort of deep dive into very narrow pieces of information. And that often results in some really interesting answers, because people don't always match the right thing to the right thing when they're trying to answer their question. Because you don't always take everything into consideration. So maybe we need some tools to help us a little bit, because there's this concept of big data. In other words, the amount of information that's actually out there is huge. We as humans probably can't dig deep enough into it to be able to get answers. So this is the free text answer question for the day. Anybody know what either of those 2 logos stand for? So somebody's recognized a Python. and somebody has recognized an R. And Python and R are what are called AI learning or machine learning software solutions. These are ways of programming that don't just answer the question like the programming tells you, but they're programming tools that along the way get smarter. That's scary. The machine is going to get smarter. You're not going to tell it. Hello? You're not going to tell it to get smarter. It's going to get smarter on the more information you give it, the more data you give it. So the one example is, and the way we can use, and we use R, is you can put in, and we have put in, 15 years worth of dispatch information. And we've told R, tell us more about this. And we came up with some really conclusions. And the first one is, during the day, put your ambulances in the city. At night, take them out the city. And everybody stands there and goes, well, of course. But who else does that? Because by tradition, the ambulance goes to where the ambulance station is. And that's where it works from. And maybe we'll send the ambulance to the popular coffee spot, because that's the best coffee. When we started giving this information to R, we would then be able to say, listen, I've just got a new ambulance into the system. It's just come back from repairs. Where must I put it? And the system will tell me, put it into that suburb. And at the moment, and this is early days, only 15 years of data, 70% of the time, there'll be a call in that suburb in the next 30 minutes. When we first started playing with this, I'm like, this is witchcraft. Like, how does the system know that somebody's going to have a heart attack in the next 30 minutes in that suburb with 70% accuracy? It's because it recognizes patterns that we as humans just cannot recognize. And what we know is the more information we keep feeding into this, the smarter it's going to get. So we're going to get to the point where we hopefully can complete witchcraft. It's going to tell us what street to go and park in, because somebody in that street's going to get stabbed. And we start seeing some really strange movements. So this was 2 nights ago at 10 o'clock at night. You can tell I do my presentations at the last minute. And for anybody that knows Johannesburg, the built-up Stanton area is in the middle, and at 10 o'clock at night, the system said, put 1 ambulance into Stanton. That ambulance did 2 calls that night in that entire middle space. All the other vehicles were put around the edges, and they were busy around the edges. That's just using some simple learning. The Australians, a little while ago, started talking about this thing called thunderstorm asthma. And they published some papers about thunderstorm asthma. And they came up with some ideas by why are there more asthma attacks half an hour ahead of a thunderstorm? There's all sorts of weird ideas about pollen and dust and warmth and dry air and all sorts of things. We're about to start a project where we're going to start feeding weather patterns into that same dispatch set of information and ask the system, what's up with this? What is it really about? How does weather really affect things? Does phase of the moon make a difference to what we do? I was very glad not to be at work last night, I'm just saying. There were just too many things lined up to make it exciting. If you don't know what these 4 terms are, you're going to struggle to function in the world that's going to be here, not in 100 years' time, but probably 5 years' time. And this is from a health technology perspective. Infotech is a term that describes how do we deal with technology? How do we deal with information? How do we store it? How do we retrieve it? How do we analyze it? Is it storable, retrievable, and analyzable? Because if it isn't, what's the point in keeping it? You've got to be able to work with it. Blockchain is another term, and everybody goes, oh, blockchain, that just talks about cryptocurrency. No, blockchain is a system of sharing information that is open sourced, reliable, and everybody gets to see it. Because there's no strange intermediaries involved. The way that blockchain works, and it's quite a difficult concept to explain, is that everybody's able to build into a central core of information. And everybody's be able to draw from it. And if anybody makes a change to it, everybody else can see. That's why it's so reliable for banking. There's no bank involved, number one. They're the worst people to deal with our money. And the second one is everybody gets to see what's happening with that transaction. So it's open, it has to be honest because it's visible to everybody. And that's certainly one of the ways we're going to be dealing with data in the future. Then there's artificial intelligence. You have to be able to engage with it. You have to get your mind around the fact that the machine will get cleverer and you have nothing to do with it. Just give it more stuff, it will learn and it will get smarter. Biotech is coming. That's implantable devices. It's the device that measures or constantly by implanting some sort of device into your bloodstream gives you feedback in terms of any sort of human conditions that are going on. This is where we're going. And everybody then turns around and goes, oh, well, South Africa, we're not going to have any of this stuff. We do. It's functioning in many, many environments. I want to pitch a story to you. We dispatch an ambulance to a case using geolocation. You've already heard that story in the video this morning. On the way, the paramedics get all the patient information before they arrive. Name, insurance status, allergies, medical history. It's presented to them electronically before they even get to the patient. So when they arrive, they go, hello, Mr. Smith. Is this still your story? They connect him to a monitor. It feeds real-time vital signs into their system. They select their destination hospital, and the destination hospital knows what's coming, knows who's coming. The file is open before the patient even arrives. Nobody repeats the question, do you have any allergies, sir? Because the system knows. The patient gets admitted to the hospital. The doctor never touches a piece of paper. He's got a tablet. Because on that tablet, the doctor is able to view blood results, radiology results, write scripts, view real-time vital signs in one place. The nurse that's looking after the patient captures her notes using voice recognition technology. How exciting does that sound? How far in the future do you think it is? What if I tell you less than 12 months? In South Africa, there will be a system running like that. The future is not fancy toys, because you know what, a defib is still a defib. You cannot make a defib better. You'll save just as many lives with a 1970 defib as you will with a 2018 defib. Don't tell the reps I said that. But it's probably true. The future is in the information these devices can give us and what we do with that information. Because once we start learning about weather patterns, we plug weather patterns in, we then start looking backwards to say, okay, cool, so what were the effects of weather? It means we have now the ability to look forwards and say, this particular weather pattern is coming, what do I expect to happen? This weather pattern's coming. I know I have to double the number of ambulances that can go and manage asthma patients. It's easy. This particular weather pattern is coming. It's going to knock all the houses down. Those are the easy ones. But we can only do that if we actually use the information that we have. Cool. That's my story.